Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0713, indicates a problem with the CVT Fluid Temperature Sensor, specifically that it is open. In vehicles like the Honda CRV from 2017 to 2022, the continuously variable transmission, CVT, is crucial for smooth acceleration and optimal performance. The CVT Fluid Temperature Sensor monitors the temperature of the transmission fluid to ensure the transmission operates within a specific temperature range. This sensor is typically located near the transmission assembly within the engine compartment, integrated into the transmission fluid circuit. An open sensor means that the circuit is broken, which can lead to improper transmission operation and affect vehicle performance. It's essential to address this issue promptly, as neglect can lead to further transmission complications or failures. The CVT Fluid Temperature Sensor plays an integral role in managing the fluid dynamics within the continuously variable transmission system. Its main function is to measure the temperature of the transmission fluid, which is critical for maintaining the efficiency and effectiveness of the transmission. The sensor is typically situated near the transmission assembly, where it is directly in contact with the fluid. This allows it to relay accurate temperature readings back to the powertrain control module, PCM. If the temperature falls outside the expected range, the PCM can adjust fluid flow and pressure accordingly to optimize performance and prevent overheating. An open circuit in this sensor will trigger the DTC P0713, indicating the need for immediate troubleshooting to avoid potential transmission damage. Several reasons can trigger the DTC P0713, primarily related to electrical issues. An electrical circuit malfunction is the most common cause, suggesting a break or failure within the wiring or connections that prevent proper signal transmission. Another potential cause is an intermittent ground short, where the signal wire may occasionally touch ground, leading to erroneous readings or open circuit conditions. Lastly, a faulty transmission fluid temperature sensor might cause the issue if it cannot properly send signals due to internal faults. It is vital to systematically rule out each potential cause during troubleshooting to ensure the correct repairs are made. Various symptoms can indicate the presence of the DTC P0713, and recognizing these can aid in timely repair. Erratic transmission behavior is common. The vehicle may experience unexpected shifting or difficulty engaging gears, affecting overall drivability. Another prevalent symptom is warning lights illuminated on the dashboard, signaling potential faults with the transmission system. Drivers may also notice reduced engine performance, as the transmission's inability to adjust to changing conditions could lead to sluggish acceleration or limited power delivery. These symptoms may worsen if the issue is left unaddressed, leading to further complications with the transmission system. The first step in troubleshooting DTC P0713 is to verify the problem while the vehicle is in the on mode. Utilizing the Honda Diagnostics System, HDS, check the parameters related to the CVTF, Continuously Variable Transmission Fluid Temperature Sensor. It is imperative to monitor the voltage readings from the sensor. If the voltage is more than 4.93 V, the current conditions match the expected threshold. If the failure can be duplicated under these conditions, proceed to the next step. However, if the system seems okay during this check, it suggests an intermittent issue. In such cases, further investigation should focus on potential short circuits or breaks in the wiring, leading to the sensor or the PCM. In the second step of troubleshooting DTC P0713, begin by switching the vehicle to the off mode. Carefully disconnect the solenoid wire harness A8P connector. The next critical step involves connecting terminals A and B using a jumper wire, where terminal A is connected to female terminal number 7 and terminal B is connected to body ground. Once these connections are made, turn the vehicle back to the on mode and again employ the HDS to check the CVT temperature sensor voltage. If the voltage is less than 0.07 volts, it indicates that the next troubleshooting step is warranted. However, if the voltage does not meet this threshold, the investigation should shift towards checking the solenoid and wiring integrity. The third troubleshooting step involves a specific check on the transmission fluid temperature sensor. Start by turning the vehicle to the off mode and carefully removing the jumper wire used in the previous step. Next, reconnect the jumper wire between terminals A and B, where terminal A is female terminal number 6 and terminal B is female terminal number 7 of the solenoid wire harness A. Once these connections are properly secured, switch the vehicle back to the on mode. And once again, utilize the HDS to measure the voltage of the CVT temperature sensor. If the reading is less than 0.07 volts, this indicates that the transmission fluid temperature sensor is faulty and requires replacement, along with potential checks on the solenoid wire harness A. Conversely, if the reading is within the expected range, the sensor is functioning properly, and focus should then shift towards inspecting for an open circuit in the SG2 wire leading to the PCM. The final troubleshooting step involves checking for open wires along the TATF line. Begin by turning the vehicle to the off mode before jumping the SCS service connector short line with the HDS, which is essential to protect the powertrain control module, PCM, from potential damage. After this, disconnect the PCM connector C, 51P. Continuity testing is crucial. Check for continuity between test points, with test point 1 being terminal number 7 of the solenoid wire harness A, and test point 2 being terminal number 37 of the PCM connector C. If continuity is confirmed, the TATF wire is in good condition, and further investigations should refer to any service information pertaining to the DTCs or symptoms encountered. In the absence of continuity, it indicates an open circuit in the TATF wire needing immediate repair before the issue can be resolved. After completing repairs following the troubleshooting process for DTC P0713, it is crucial to conduct a final verification. Start by confirming that the issue has been effectively resolved, ensuring that all faulty components, including the temperature sensor and any damaged wiring, have been replaced or repaired. A test drive is an essential next step. It allows for real-time evaluation of the transmission's operation under various conditions and confirms that the vehicle shifts and performs as expected. Following the test drive, recheck for the DTC using HDS to ensure that it does not reappear. This confirms that the issue has been resolved and that the vehicle is functioning correctly. If the DTC does come back, further diagnostics would be necessary. Focusing on other electrical components or possible PCM issues that may not have been addressed. To help prevent issues related to DTC P0713, regular maintenance is key. Start with routine checks of the transmission fluid to ensure that it is at the appropriate level and in good condition, as degraded fluid can lead to temperature anomalies and sensor problems. Additionally, inspecting wiring and connectors regularly for signs of wear or damage can proactively address any electrical circuit issues before they become problematic. Keeping the transmission cool is also crucial. Make sure that the vehicle's cooling systems are functioning properly to prevent overheating, which can exacerbate electrical failures and sensor readings. Following these preventive measures will help maintain the integrity of the CVT system and minimize the chances of encountering the DTC in the future. In summary, Understanding and addressing DTC P0713 requires a comprehensive approach, from identifying symptoms to following structured troubleshooting steps. Recognizing symptoms early, such as erratic transmission behavior and warning lights, can help prevent further complications. By systematically working through the troubleshooting steps described, technicians can effectively isolate the problem to either the sensor or the wiring leading to the powertrain control module. Ensuring proper functionality of the temperature sensor is paramount, as it directly impacts transmission performance. By adhering to preventive maintenance recommendations, vehicle owners can help mitigate the chances of encountering this issue in the future, thus ensuring their Honda CRV remains reliable and efficient. Please like and subscribe to the channel. See you next time.